Okay, we will continue our hands-on programming session.
Know about anybody else, but I find the dark theme almost invisible against the.
Oh,
It's because of also the contrasts. There's white and black.
Well, but you also have the contrast with the backdrop. Oh, it's very bright.
right. I can change the theme.
Dark theme is good for late at night bed.
Right. Light 2026. Is it better? Okay. Okay.
Awesome. You can also get rid of the two sidebars.
Right.
Backing so man B and man.
Ah. So I can close this as well. Yeah. Okay. Actually, I just wanted to ask you, how many of you finished the first step? Step 1? Okay. Okay.
Exercise.
Oh, exercise. Okay. You're still working on this. Yeah. So first exercise will be modifying the grid manager. Yeah. Actually, if you look into the next step, you can find the hint here. Yeah. In step 2, inside this inconsistent grid manager. Yeah. This is the example implementation. So you can put this as a constant minimum safe balance. In this case, it's negative 200 megawatt. And this is something called preamble. Actually, we have the explanation for the preamble in the markdown. Yep. So you can use preamble for target language specific declarations. For example, in C, you can put pound define or constants like this. Yep. This is an example. If current balance plus the command, and if that value is greater than or equal to the minimum safe balance, you update the balance for the state, grid state. If not, then you just reject the command and print out this warning using lf print. And yeah. For example, very simple. Example. Oh, actually, it's AI autocomplete is a little bit annoying. Can mute it. Okay, balance. Okay, and once you're done with implementing this logic, then you can run a scenario where both managers um, start at balance of negative 150 megawatt, and California curtails by negative 80 megawatt, and your dispatches up by positive 100 megawatt. Yeah, which will cause a problem in terms of inconsistency because of this logic.
I don't know if you can explain what the acid 2.0.
Oh yeah, we didn't. Right. Yeah. So we want to have the consistent view of the grid state between these two regions, and this adding this command value to the balance has a mathematical property called SC 2.0, and that means that this operation is associative, meaning that it doesn't matter whether we apply this first or this first, and also it's commutative. It doesn't matter whether we change the order of operands for the operation, and it's also idempotent. That means that the command will only be applied exactly once, because we are using TCP connection, so there will be no duplicate messages, duplicate comments. And also distributed, meaning that the state is maintained at multiple nodes. Yeah. And such data type is also called CRDT, conflict-free replicated data type. However, because of the logic, the safety logic that you added, we will be breaking this property, ACID 2.0 property. Yep. Which means that, so starting from negative 150, if you apply this first, then that command will be rejected. So the state will remain 100, negative 150. Then if you apply, so let's say we have two options. We can apply this first and this later, right? And then what would be the final state in that case? If we apply this command first and this command after that, what would be the final grid state with your logic here? Okay, so the answer is it'll be negative 50 megawatt. Yeah, because this command will be rejected by this modification, and later the green state will be dispatched up to negative 50 megawatts. Yeah, but if you apply this first, then this later, what happens is the balance will be updated to negative 50 megawatts, and then it'll be decreased by 80 megawatt. So the resulting state will be 100 negative 130 megawatt. Yeah. So that breaks this associativity of the SE 2.0. So the resulting value will be dependent on the order of applying these operations. Yeah. Which shows the importance of keeping the intended order. Yeah. Sorry?
Okay.
I think that tells whether like 150, sorry, negative 150 plus positive 100, 100. Yeah. Actually, yeah, it's still commutative, but it's not, it becomes not associative anymore.
But it's not clear. It's still commutative either. I don't think it's either. Even or session. Like commutative means you could reverse the order of the operations, but if you apply the
I think what it should be the current balance, right?
Oh.
Balance and value.
Initial amount plus A plus B or initial amount plus B plus A.
Yeah, so for example, let me type in here. So I think the problem here is
Yes.
right. Yeah.
commutative, and it's also that's right.
Ah, okay. I know what you mean. Okay. So to demonstrate this, so this will be different from this, because this operation will not decrease the balance by negative 80. Yeah. But can we tell whether it's commutative for more than two operands?
Yeah. Because the order we get.
I see. Got it. So
Yeah,
right. We need a mathematician. But either way, it'll break the SC 2.0 property. Yeah. Because now the order matters. Yeah. No, right. Same thing. So I just implemented the logic to discard the operation, which will cause the balance less than negative 200. And maybe we can send these comments simultaneously and see. I'm not sure whether this one will go through first or whether this one will go through the message from here or I can try. So here, actually, this time plus 100 went through first. So both of them sees the same balance. So right now it just depends on which message actually arrives early on the grid manager. So you mean controlling the timing in the Lingua Franca program, or so? Yeah, it can be given as a parameter, input parameter, command time. Yeah. Oh, actually, I forgot to change this to uh okay. So now the New York interface will send command earlier than California. Why put a different value? Should be 100. Now we should see 130. Negative 130. No. Sorry, actually, didn't make the initial value 100, negative 150. You'll be seeing. So this will be rejected, and so yeah, we should see negative 50 megawatts because we applied the this operation first. But if we change this order so that we apply this command first and this command later, should I exit here as well?
But not R.
Command B?
Yeah.
Okay.
Also, except from another moment, restart programs.
Oh, I didn't know that. Okay. Yes. It was hidden here. It doesn't work. Turn PD. Okay. Yep. This way you can try both cases and see the different results. Okay. How many of you finished the first step? Okay. Yeah, I can see some of you are still working on step 1.
Oh, that's a different question. Reading my email.
That's true. Okay, maybe we can start moving on to step 2. So now that we have this, we added this logic to reject potentially dangerous comments, and this breaks the consistency. Can break the consistency because the message will be handled in the order of receiving these messages. So, yeah, these two grid managers may see these messages in different order. Then you may end up with different grid state. Yeah. So yeah. So this is a visualization of the inconsistency. For example, if let's say California node sends curtail comment to reduce the balance by 80 megawatts, and then New York sends the dispatch command to increase the balance by 100 megawatts, and the grid manager 1, which is California, if it sees this first, and then this will be rejected, and then this will be applied. So this grid manager 1 will see the final balance of negative 50 megawatt. Yeah. But On the other hand, if grid manager 2 sees this message earlier, right? Mm, yeah, then it will apply this first. The balance will be negative 50, and then this will be applied later. So we'll end up with a negative 130 megawatt. So we will see this inconsistent grid state. And actually, this can be addressed by using the logical connection instead of the physical connection with the squiggly arrows, and by adding this max weight of 100 millisecond.
So this is using decentralized.
Yeah, exactly. Yeah, exactly. Actually, all these lingua franca programs are in decentralized coordination. So this is first one, and step 2, it's also decentralized. And the change you'll be making is just changing these squiggly or tildes with hyphens and adding max weight for grid managers. So
This is-
like this. And with this change, now instead of using the time of receiving these messages, we'll be using the intended time, the logical time of of these messages. We'll always have the consistent value. Yeah. Yeah, maybe I can ask you this question. What if we send these two messages at the same logical time? In what order should they handle those messages? Actually, that depends on the logic in the this reaction. So in this case, we always handle. So assume that we received comments from these two grid interfaces with the same logical timestamp. Then we can guarantee that we will always handle the message from the first input port, right? Which is sent from this interface at the top. Yep. But we have to be careful because um, the command from the top grid interface should be connected to input 1 of both managers. If we mess this up, we'll end up with the inconsistency. Yep. Is everyone done with step 2? Okay. Shall we move on to step 3? So yeah, step 3 starts from start from the modifications that we made as shown here. Yeah. Oh yeah.
Oh yeah. Okay. Okay. You go to step 2. Listen. Okay. So did you use next week of 100? Yes. That means that the message arrived with a delay over 100 weeks. So that's very unlikely. Yeah. But how about you increase the next week value to 50? I mean, isn't it like 500? Yeah. It looks correct. Increase some.
Actually, I never got STV violation because all these federates are running on the same computer. So, yeah. But I wouldn't say it's impossible. It's possible, but it's very unlikely. Right.
Or something.
Then that's
Yeah.
it. Go.
Yes. What do you Yeah, the inks, right? I think really interesting. So you Emacs. Sorry. Are you Emacs? Oh, yes, okay. I don't like this. I found this here. So we're getting a STV violation here inside the grid interface, not in grid manager. So we need to probably also need to add max weight on interface as well. Well, which will then go with on interface. Or alternatively, you can set an empty target in Canva. Yeah, if because you actually don't really care about the order. That's right. Right. Yeah, that's true. Yeah. Okay. That might be worth explaining.
Yeah.
It's an interesting issue.
So actually, that was a great question. So if you run this program as is, like this, actually we will get safe to process violation on these reactions, reaction 3 in grid interface. But actually, it doesn't really matter even if we receive the delayed message here. So um, as Edward mentioned earlier, what we can do is to add empty tardy handler like this. Yeah.
But the meaning of that is it says if you receive a status message out of timestamp order, what has happened, can you expand it?
Yeah. Oh, it was collapsed again.
What has happened is that the grid interface has advanced to one of the 2 clock times. Doesn't matter which one, right? Message is out with that timestamp, and then a message comes back with the same timestamp to here, but it's already completed the execution of that timestamp. And so it says, this message is late, right? Yeah. But you might, in certain circumstances, you really only need for the order of these messages to be preserved, right? If this is just reporting, for example, or logging, right, then you just need it to be logged in the right order. So this notation says, this is normally used to specify a handler. So you can specify a chunk of code after this to handle the error. And what will happen then is if you get a message out of order, it'll execute that code instead of this code. Right. But if you leave out the handler, then it just says, okay, just execute the original code and don't complain.
Right. So it'll be different from, for example, this. Because in this case, although it's empty, this part of the code will be executed without instead of this. Yeah. Oh yeah, right. Okay. Maybe we should not call it empty tardy handler. Right. No handler. Okay, so this is no tardy handler. Or
There's three sun.
right.
What's the need?
Right. Maybe we should clear definition of these three cases.
Yeah, probably this is not the best syntax.
Right. Right. So yeah.
May want invent a better syntax.
Right. Yeah, that's a really good feedback. Yeah.
It's also unfortunate that this gets specified in the reactor class rather than the instance.
Right. Maybe we should just put max weight forever.
No,
Oh,
then you get lock.
right. Yeah.
And actually, and even a finite that's way to do it solve the problem because it won't advance the timer
Right.
in interfaces until it's decided the input is empty.
Right. So the log messages will be delayed by that value.
Yeah.
Yeah.
So you need the annotation that tardy messages are okay.
Right.
It's called no complaint.
Oh, it like
No complaint.
no complaint.
Yeah. So if I did an empty, I did this without the empty header, it's okay. It does with max weights.
Oh yeah.
So I did army and max weight for GA1 and GA2. Still got the error.
Oh, really?
Studies. It was called and max weight for all.
All reactions or all reactors?
all the-
Or maybe that the max weight of 100 millisecond delays other reactions as well. So that'll cause STP violation on managers.
You have the max weight.
So if you add I can show you. Yeah. So if we do this, okay, I think the problem here is that this will react 100 millisecond. No,
This won't solve the problem at all, right? Because what this means is to process one of these timer events, you need to know about the input,
right.
and you don't know about the input. So
Right.
100 milliseconds. Then you assume the input is empty. You go ahead and process this event, produce an output, and then this guy will wait another 100 milliseconds because it doesn't know about the other guys. So the message will get fed back 200 milliseconds later, same timestamp. It'll be tardy for sure, right?
But he already put tardy.
I think
So I think the STP violation will happen here if we make this one is
right. So yeah.
Mm-hmm.
So if we make this 100, then what happens is this reaction will be delayed by 100 milliseconds because of this. And then when it arrives here, it's already 100 milliseconds plus alpha late. So the STP violation will happen here.
No, if the SCP violation doesn't happen unless you've processed an earlier event. So the only way you get an STP violation here is if this guy has arrived with the same or greater timestamp.
Right. Oh.
but we also create that part.
I think the right solution is to
Just add party.
for this guy.
Only party. Okay. No max weight.
See, that's the only solution. Actually, there is another solution, which is to specify something we haven't talked about at all. But there's something related to max weight, which is called absent after.
Mhm.
And you specify it on a connection. So that's actually the better solution, because this is a zero delay loop.
Mhm.
Absent after is meant for zero delay loops. So,
So remove this.
Can you set this to so it expands by default?
Yeah.
Keep losing the
Sure.
errors.
No, not here. Yeah. Yep.
Okay. So, can you put on this connection? Since this is this is
Grid manager to grid interface.
grid manager to grid interface.
Yeah.
Absent after 200 milliseconds. No. You do it with an attribute before the connection.
Mhm.
Absent until after. And so this appears on the diagram like this. Okay, so the meaning of this now is that when the grid interface sees an event from one of the timers, it pays attention to its max weight, which is by default 0. So it'll go ahead and advance to the time without time, but it doesn't yet assume that this is absent. Okay. If it executes any reactions that don't depend on inputs, but when it comes to wanting to execute a reaction that does depend on inputs, it doesn't assume the input is absent until 200 milliseconds later. So this should also solve the problem, and it does it more nicely because now all of the annotations are in the system architecture rather than in the class definitions. Okay, so which is really what it should want, because the timers you want, the times you want here depend on their actual deployment, not only class definitions.
How do we have to calculate this 200 milliseconds?
Well, the reason I picked 200 milliseconds was because this max weight of 100 milliseconds, it's already going to delay the feedback by 100 milliseconds. So I wanted to give it some more time.
So if you do it incorrectly, that also happens.
Right.
If this time is too small.
Right.
So I would say that it's not an aperture lamp.
Right.
So for me, it won't work.
Yeah. So the absent after is only needed when you have zero delay loops. That's the only time that it has an effect.
Right.
Or, well, it has an effect whenever you find it, but it's the only time it's actually needed.
Right.
Right? Because the issue is that you want to go ahead and advance time here, but you don't want to assume the input is absent.
Mm-hmm. Mm-hmm.
The absent after messes up the layout, doesn't it?
Yeah. Oh, I think that's because this connection.
Well, so the layout algorithm here is several PhD theses as work. It's actually incredibly hard to lay out these diagrams. It's all been done in Q. Really quite sophisticated, but they're putting components in columns. And for some reason, this is deciding to put this in the column with this and this in the column with that.
Yeah.
Ask the guys in the field.
Yeah, I think this could be moved.
What it really should be to
we can compare this. Yeah, this annotation could have been here.
yeah, but notice it didn't move this guy out, right? So it should have been what I would want would be annotations and these two guys all the same.
Same column. So that we will have only two columns.
There would be only two columns.
Okay. Okay, so I think sure.
He looks for problems. Find some interest.
Okay, good.
Let me find out what.
Yeah, actually in step 3 we had tardy. Yeah. Yeah. We already had that. So yeah, step 3 it explains two messages because now we are using the logical time. There can be two messages with the exactly same timestamp and also microstep. So we need to have a deterministic order of processing them, and we need to make sure that they're connected to the same grid interface. Like input 1 should be connected. For example, input 1 is always connected to California grid, and input 2 is always connected to the interface of the New York grid. Yeah, it's shown here. Yeah.
Only out of the person. Out of the
It's fine. Yeah.
But if I point as 10 in seconds period, number as 20 in seconds.
Different periods.
Yes, and can I still listen to also or can I still do the same loop according to that?
Oh,
Then we will have
I think I don't think it matters. So you mean, so instead of having a single grid interface, we can define, let me make it a little bit smaller. Another grid interface. Let me call it grid interface 2. And it has different period. Shorter. Okay, like one second. Okay. Yeah. So I can make the New York grid has a shorter period. Yeah. Yeah. So yeah, as you can see.
multiple.
Oh yeah. More. We'll be receiving multiple comments from this New York grid, while California grid gives one comment. Yeah.
Yeah. So what that means that in some reactions, this input will be present and this one will be absent.
Yeah.
Okay. If you just read the value, you actually just get the previous, whatever the most recent received values. But you can test it for is it present, right?
Yeah.
Instead of looking at the value, you look at is present field.
It's present means whether it's the vacuum that's been updated since the lesson.
Right. Is present means it's present at the current logical.
The current logical.
Yeah.
Right. And I think it understands that there will be, so for example, there will be no messages
subs. So if it's present returns false.
Right. Yeah. So can we look at your grid manager reaction? Because I suspect it's another. Needs to be tough.
reaction.
The
Yeah.
Oh yeah, it is checking. It's checking for presence.
Yeah.
I was
Yep.
curious what that's the
Otherwise,
I was curious about the meaning.
Ah, yeah.
you nailed it.
Yeah.
Right. Yeah, there was a debate in the Lingua Franca community about whether if the input is absent, should it have a value at all?
Mhm.
And there's actually two different resolutions of that. In the CPP target, it doesn't have a value. And in the C and Python targets of depth, it has the most recently received value. So it's two different semantics. But
Well, how do you specify non-existent value? By null or
in CPP, it's a null reference.
null reference. Okay.
Yeah.
And in this case,
But in C, you can't do that because the values are primitive C type. Say it's not value, but the values in it, the fields in it, how do indicate an absence? Right? And it, you just have to add another level of indirection, which the CPP target does.
right. And also in this case, for example, if we implement this this way, that there will be no message output. I mean, there can't be any output at 1 second. Actually 1.5 second, right? It's impossible to this reactor to output a message at 1.5 second, right? So at 1.5 second, there can be only yeah. So 1.5 at 1.5 second, we have this output.
Yeah.
Right. But there is no way that this guy can produce output at 1.5 second. And in this case, if we try to read the value, will that be 0 by default? Because
It'll be whatever was sent to the 500 milliseconds.
you're right.
If there hasn't been any message sent at all, then it'll be 0, whatever 0 is from the data type.
I see.
Or an integer is 0.
For example, if I change this to this or yeah. Oh no, not this one. My intention was to change this. No, actually, in this case here though. 200, 2,500. Oh, actually, we have instruction to intentionally trigger the STP violation by removing tardy and making the max weight very small. Yeah. Yeah. So actually, this is wrong. It should be just tardy, right? It doesn't have this.
So that
Mhm.
handle
Mhm. Mhm.
then has only overhead.
Sorry. Well,
Only create small overhead. So
if we have tardy like this,
this has more overhead.
it's more overhead, and also if the message is late, this block won't be executed. Yeah. So it's very subtle. Yeah.
So if there's a handler, then you will not execute
Yeah.
what's inside. But
Only this part.
if there's no handler, then you will execute.
The reaction. Yeah.
You still execute.
Oh yeah. So if it's no tardy handler like this, it'll still execute the reaction. But if you have empty tardy handler, this will not be executed. So yeah, I think we should.
These are different semantics.
Yeah, we should change the semantics.
Yeah, if anybody has ideas for a better syntax,
Yeah.
syntax is really quite new. So
Yeah.
but there are 3 things you do. Well, actually, 4, right? the default is tardy, if the message is tardy, you get an error message and the original reaction executes.
Mhm.
Okay. Yeah. But so one option is you don't want the error message, but you still want the reaction to execute. The other option is you don't want the error message and want an alternative piece of code. There are more options.
Yeah, that in total four. So error code, reaction, targeting editor.
Right. Yeah, I guess the fourth would be
And then
no error message and no code back.
Best case scenario, 2.2.
Yeah. So those are all implementable with the syntax. Very confusing when later
Yeah,
you're getting. So the syntax is
I only know it when we start to code.
yeah.
Oops. Sorry, what was the fourth option?
No error message and no code into that.
Just let's do your have.
This one.
No. Just what you have now. Let's put this.
I see.
Yeah. The handler that have not
It has no empty body.
the empty part of the handler.
I see.
Empty part. But I don't. I will differentiate because to read because you have a message is part of the. It's part of the reaction package.
Well, if you provide them, right? Right.
I did differentiate as well.
You don't. It's just
You just said it. We do whatever else you can eat for things. You said you guys use easy to learn.
I thought computational world that okay. It's TP validation error, and the original reaction is not.
it is executor. If you look at the error message, what the error message says is STP violation executing the reaction at the wrong time.
Oh yeah. Okay. So this is SPP violation.
Uh,
Right. Yeah.
Question about the times. So this about the next. It's about step.
step 3.
So then you write something about that the network delay and the clock still error is less than the megabyte.
Sorry, where?
Yes, but down. So this is correct. As long the clock signal the network latency is smaller.
Here.
What about the execution times of the functions or the reactions?
Oh yeah, including that. Yeah.
We refer to the combination of network latency, clock execution error, and clock synchronization error, and no, sorry,
Computation time.
network latency, clock synchronization error, and execution time. We use the shorthand LEX. L for network latency, E for clock synchronization error, X for execution error. And those are only ever considered as a sum. You never split them out. In fact, it's impossible to tell the difference between network latency and clock synchronization error. There's no mechanism for telling the difference. And execution time just adds to the latency, so today it's got it right.
So it's LEX. Lex.
LEX.
Okay.
It's a shorthand for tired. It's an old word.
See, yeah. Now I updated the description. Oh, I think we need to update this as well. Yeah, and the exercise here for step 3 is to change the max weight on both managers to forever. And see if this still runs. Yep. It still runs, but you can see the lag. Yeah. Also, actually, we can. Oops. We can actually make it completely stop by, for example, we trigger the reaction, but not producing the output. For example, if we remove the code for setting the output from grid interface 2, which is for New York. If we run this again, yeah, as you can see, although this grid interface, California grid interface, is sending commands, none of the managers are reacting because they're waiting for the input from grid interface 2, which will never come. Yeah. Yeah. That was step 3. Yeah. And step 4, yeah, sorry. Oh, yeah, yeah, yeah. So I can show you the code again. Yeah. So I changed the code so that this grid interface 2, the reactions in the grid interface 2 will be triggered with the timer, but it never produces output. Yeah. So yeah, these grid managers are waiting for the message from grid interface 2, which will never come. So that's why earlier we saw grid interface, the first grid interface progresses while all other reactors, yeah, just stop progressing their logical time. Yeah. So yeah, step 4 is to address that. Uh, no, actually, oh yeah, yeah. This is the conservative coordination by making the max wait of the grid manager forever. But actually, yeah, as you saw, the grid manager will wait indefinitely if the other grid interface never sends the message. Yeah. And this can be fixed by allowing null messages. Actually, Edward mentioned this earlier. Yep. So the meaning of null message is that it's confirming that there is no there will be no message. Yeah. So there is no real command to be sent, but just sharing the current timestamp. Yeah. So that's the null message. And so yeah, this was originally proposed for distributed simulation. Yeah, by Chandy and Misra in 1979. Yep. So with this, you can get strong consistency and bounded weight. So here the bound is the period of null messages. Yeah. But at the same time, we give up the availability under total failure. For example, if actually here we used something called import and also hierarchy. Yeah. Oh yeah. It's a logical time period. Yeah. So if you look at step 4, we have something called grid server instead of interface with the operator console. Yeah, which is included reactor. So there is a hierarchy between reactors. You can actually include a reactor inside another reactor. Yeah. And we can create a timer for null messages. Yeah, like this, which can be given as parameter input parameter, and we have this reaction to which will send null message. Yeah. In this case, it's just 0. Yeah, it doesn't affect the grid balance. Only when the actual command input does not exist. But if the grid server or the grid interface crashes entirely, it won't be able to send null messages either. Then the New York manager will wait indefinitely, as you saw before. Yeah.
The actual network partition is really
Right. If it was a actual network partition, then it'll wait forever. There will be yeah.
so you need to actually put the null message.
No, even with the null message. Yeah.
Just should put the no message manager.
Somewhere else.
And then you don't receive the lower message from the other side of the pixel.
Yeah, or we can just set max weight not forever. Yeah, with a finite value. Then yeah,
Well,
yeah.
you can also, you can set the max weight to a finite value and then put an identical timer in here. Okay. And that identical timer can detect the absence of this message. Okay. And react. Oh. Yeah, that's what you're at.
So timer here with the same period as no message.
Yeah, one of the really nice things about Lingua Franca is when you have two timers anywhere in the system, wherever they are, have the same starting time, same period.
They will be perfectly synchronized. Yeah. Yeah. Yep.
So that makes it very easy to detect the absence of a quick message, right? Which is really hard to do with puffs up. And try doing that once. Can you detect the absence of a message that's done? When should you do whatever? But you keep puff out. It's just the person exists. Yeah. There's no mechanism of time most of it. Yeah.
So yeah, here are some exercises. So for example, here we can consider that the dispatch up command is safer to process, right? I mean that's because at least there's no risk of causing blackout, right? So it's safe to process the dispatch up message earlier, even if the other message comes later. So, yeah. To do that, we can create a new reactor called quick dispatch.
That's on the assumption that it's safer to have too much energy in the system.
Right. Yeah, that's the assumption. Yeah, yeah. Assuming that we have enough capacity to hold excessive energy generated from the power grid. Yeah. Actually, the solutions for these exercises in step 5. So hybrid design. So that we can fast path, provide fast path for safe comments, the dispatch up comments. Yeah. While we will be more careful with the curtail comments. So this is quick dispatch. Oh, you mean the explanation? Yeah. Right. It only handles positive comments and acknowledges immediately. Yeah. Oh yeah, grid manager has a max weight of forever. Yeah.
What's the dispatching will be managed?
Yeah, so the dispatch command will be acknowledged, but it won't be executed.
Oh.
Yeah. And then
So grid manager spend output goes to a quick dispatch,
mhm,
and then a quick dispatch directly acknowledge the
positive comment. Yeah. Yep. And grid manager will make the final decision, and it'll update the quick dispatch reactor with the actual balance. So, yep. Maybe I can collapse this a little bit. So now the command from the grid server or grid interface is wired into the grid manager as well as the quick dispatch reactor. Actually, I just realized that this is not wired anywhere. Acknowledgement.
oh, goes to a black hole.
Right. Yeah, it's ignored. Yeah, I think we should stop here. It's 5:50. Yeah, yep. And okay, I hope you enjoyed this tutorial. And we have a link for the survey, participant survey, to get your feedback and provide better experience next time if we provide the tutorial. So I would really appreciate if you can fill out this survey.
Yeah, of course you want.
Yeah.
So you put the physical time in the semantics, but you don't know a logical time. The logical time into. So for each advance in the logical time, has an advance in physical, right?
Oh yeah, the physical time advances automatically by the local clock
And the specification we put is now in the physical time. Like a microsecond, milliseconds, they are all in physical time, right? How do you want to map it? What is the physical time unit of a logical time? Physical time unit of a logical time. So let's say your logical time advances by one. How much time does it cost to physics?
Well, physical time. We wait until the physical time passes the intended logical time.
Yeah. So if we don't do the worst case analysis of the logical time, then the specification of the physical could be too optimistic. Right?
Yeah, it's so usually the goal in the Lingua Franca program is to keep physical time and logical time reasonably close to one another. Because that's how you specify the timing of graphics and program. But it's always possible for create a program that doesn't keep up. Just lags. So we use the term lag for the correct physical time minus the correct logical time reaction. And you can make programs where the lag increases without bound. If you use the fast option, the lag becomes negative. Right. Not usually. I mean, unless you're unless you're too much on the place.
That's it. Maybe it's also a perspective to assume that maybe the physical time interval only is only violated from time to time, but not always, right? So as long as you somehow can do that in a logical time order, then it looks fine. The question is, since now we have the physical time in the Lingua Franca program, but there's no map to logical time. If I have this teleological time, everything may still be fine. But now if I have to specify some of them with respect to physical time, and the program actually only focuses on the logical time, and maybe there's some discrepancy. It's right. I'm trying.
Yeah. So there's a construct in Lingua Franca that syntactically functions like a target element called the deadline.
Yeah.
The keyword is deadline. Okay, and we specify time values. And just when you go to a global reaction, if the lag increases, if the lag is higher than the deadline threshold, then you invoke the deadline violation tag instead of the regular reaction. Right? So that's treated as a fault condition. Right. So if your application needs for the lag to be bound to the deadline to the deadline.
Yeah, that's what I'm hearing.
Some applications don't need that, right? And so,
Yep. So yeah, you can add the deadline handler for the reaction, and if the reaction is triggered with a lag greater than this deadline, then the deadline handler will be executed instead of the reaction body.
Regarding the start of the action. Yeah.
Right, yeah, triggering of the reaction. Yeah.
just cause endless debate.
Right. And yeah,
Keeps wanting to change it.
we can also check the deadline during the reaction execution. Yeah, we have an API called LF check deadline, and it'll check the current lag during the execution of reaction. And if the lag is greater than, actually,
You can do this, for example, that monitor their own execution. And when they see the threshold, they return what they've computed so far. So those are called anytime algorithms.
Yep.
It's not the proof.
Oh, right.
oh,
Anytime goes to you.
Oh,
But the next step is anytime goes to you. That's what I wanted to say as well. We have from any kind logical reaction. So it violates your physical time expectation and complies with your logical time expectation. This may be a little hard.
yeah. If you're getting simulations, like, what Chandler was showing where, the simulation was lagging, right? So, physical time was getting way ahead of logical time. And if her simulation was closed, that doesn't really matter for simulation. Right? You can just record all the events and then play them back in real time later or else. But in her case, she had real time inputs. The camera inputs were coming in real time. And so the lag now becomes a problem because, the camera inputs have timestamp in the current physical time. The current physical time is way ahead of logical time. So the camera inputs don't get processed for a while, so you don't see the effect on the screen. It's always true of real-time systems. They don't necessarily keep up with real time.
Although they are supposed to.
They're supposed to.
Yeah.
Yeah. So the important thing is to be able to be able to detect the violations and
Right.
no,
we need to do that in the source to public, right? So we specify all the cancelled actor, sorry, the actor, and then you can say decide whether you want to start it now or you want to let it run further. So yeah, and then you need certain mechanisms to allow you to that as well. You need a fault handler.
Right.
We need a fault handler. And we make a fault handler. In this case, it's required, right? You can't specify it as one without providing a fault.
Yeah.
Syntax requires it.
Mm-hmm. Although the programmer can still leave it empty.
It's actually, it's sometimes as a good thing we do. It's saying, I don't want this reactor. It's not on.
Okay. Yeah. If it's too late, yeah.
If it's too late, don't process this.
Right. Yeah.
Right. The car has already crashed. Don't press the brake.
Yeah, maybe the car still tries to keep going even after crash. So in that case, you still.
Well, shall we go to the reception?
Yeah, sounds good. Yeah, thank you for joining the tutorial. Yeah.